So here's a bonus video where we're looking at the chi-square test of association. So this goes with 11.2 in your book. And a good idea would be to turn to page 716 for some basic expectations or just basic descriptions of what goes into it. So we looked in chapter 5 at the relationship between gender and allergies. And we had this two-way table where the observed counts of allergies and no allergies and then gender, female and male. We found that they were not independent, meaning if we knew that you're female, it changed the probability of allergies, and vice versa if you're a male. So let's see if they're associated. So the chi-square test of association. So let's first start with how to do expected counts. So expected count would be, if we expect that the two distributions were the same, we'd expect that the total proportion was reflected in each individual sample. So 18 out of 40 times 23 would be what we expect for females. We've done that before for the test of homogeneity. So one thing in addition to that I want you to know is doing this on your calculator. That's described down here. So first I'd like you to go to the second x-1 button, matrix, and then go over to edit, matrix A. Rows by columns, so it's a 2 rows, 2 columns. Don't include the totals, so we're just including these 4 boxes here. And then quit. You'd go to stat tests, chi-squared test. Observed would be matrix A, expected would be B, and then hit calculate. So that's awesome because it gives you the chi-square and it gives you your p-value, which is incredibly high here. We only had 1 degree of freedom. Remember, rows -1 times columns -1, so essentially just one box that's free. Everything else is determined by that box and the total columns. And we end up with a really high p-value. Then what else it gives you, though, is the expected values. So now if you go back into the same function and go to edit, and instead just hit B, you'll find that under B you have all your expected values. So it's a nice shortcut once you already understand what's being done. Now you should also understand where that comes from. So that's coming from the fact that if the two distributions were the same, then we'd expect the proportion of females with allergies to be the same as the total. So 18 over 40 had allergies total times a sample size of 23, which gave us our expected count. So knowing that is fundamental to what chi-square is. Once we have that down, though, a nice shortcut is using this matrix function, and make sure you're doing the chi-squared test. We'd use chi-squared goodness of fit if you have an 84. For the goodness of fit test, we've already gone over. So we just did the majority of the do part of the question because that was the part I wanted to focus on the most. The other difference is just the null hypothesis would be the statement of no difference. There's no association between the two variables from the population we're interested in. If we can find that we can disprove that, then we can say that there is an association or alternative. Random conditions the same. Remember that we have the large sample size for a chi-square, so all expected counts need to be greater than 5. They are. Now the independent condition. If we had a comparative experiment here, you would just be looking for random assignment to assure that observations are independent, that we had a treatment group and a control group that are roughly equivalent. And we wouldn't worry about the 10% condition unless we're sampling without replacement. Here we're sampling, meaning when somebody gets pulled out, they don't go back into the population. So the 10% condition, we can't sample more than 10% of the population and have our calculations hold up. We also know that observations should be independent, so knowing one response of one student should not affect another. So here we'd have observed minus expected. 1 degree of freedom, so remember 1 would be the mean of our curve there. You show the first two terms of chi-squared, and you can do plus ... That shows that you know what chi-squared is and how to apply observed minus expected. We have an incredibly high p-value, which means the null hypothesis that there's no association is plausible. So we fail to reject. So we do not have sufficient evidence to show that there's an association between gender and allergies for this population that we're concerned with. So review this test of association, test of homogeneity. One of your free responses on your final will be one of those two. So be ready to go on that free response. And then just look over the rest of chapter 11 as you get ready.